Key, looking at this first one, we're just taking the cube root of negative 64. The cube root of a negative is still negative, and the cube root of 64 is just 4. So that's one of the perfect cubes you should know. If you look at number 2, let's deal with the powers first. We have an x and an x. They just cancel. And then the y to the negative first moves down and makes that y cubed. And then 4 over 16 is just 1/4. So the answer is just 1 over 4y cubed. If you look at 3, that's negative 32 to the negative 3/5. So that's the negative power is going to move that into the denominator. And then we can take the 5th root of negative 32. That is a perfect one, so that's negative 2, and then negative 2 cubed is negative 8. So we get negative 1 over 8. All right, number 4, 27 to the 2/3. Well, let's take the cube root first. So, don't try to do the 2/3, just do 1/3, which is the cube root, and get 3, and then do 3 squared to get 9. So just do them in pieces. Almost always do the root part first, meaning the denominator first, just like we did here. We worked with the 5th first, and then we cubed it. We did the 3rd first, and then we squared it. Okay, looking at 5. This is a power to a power, and so we're going to multiply. So 2/3 times 3 is just 2, and then 1/4 times 3 is just 3/4. And so 4 squared is just 16, and 5 to the 3/4 is just what it is. It's 5 to the 3/4, or in radical notation, it would be 5 cubed to the 1/4. You can leave it as 5 cubed, or you could write it as 125. Doesn't matter. 6, if we're going to add and subtract those things, we have to make them look identical, meaning they have to be like terms. So the first 5 radical 5, this part is totally fine. It is what it is, but then we have to make square root of 45, 3 radical 5. We split it up into 9 and 5. Square root of 9 is 3, and then 5 radical 5 minus 3 radical 5s. Well, that's just 2 radical 5s. It's like 5x minus 3x. 7, we're going to rewrite that as, instead of x to the 4th cube root, we're going to write it as x to the 4/3, and then x to the 5/2. We can combine those. That's just adding fractions. 4/3 plus 5/2 is 23/6, because 4/3 is 12/6. 8/6, and then this is 15/6. 8/6 plus 15/6 is 23/6, and then to the negative second would be x to the negative 46 over 6, and then 46 over 6 is really 23/3, and then the negative made it flip to the denominator. And so we can write it like this, which would be the same thing as this. All right, number 8, we're just adding these. So let's make these 15ths. 10 15ths plus 3 15ths is 13 15ths. Number 9, we are going to split up this 32 into 8 and 4 because we know the cube root of 8 is 2. We're going to take out 3 of the x's and make it an x. We're going to take out all the y's. The cube root of y to the 6th is y squared. We're going to take 12 of the 13 z's. The cube root of z to the 12th is z to the 4th. And then we left behind a 4, 1x, and 1z, which is just needs to chill here under the cube root still. 10's the same thing. We're going to leave, it's just the square root. So we're going to take the square root of 4 and get 2, the square root of x squared and get x, and the square root of y squared and get y. And we had to leave a 2, and we had to leave a y. Okay, this one, a little more complicated, but we got 8 to the cube root, and then y to the negative 4/3 times 1/3 is negative 4/9. X squared to the 1/3 is x to the 2/3. So the cube root of 8 is 2. X to the first, x to the 2/3. Well, that's just x to the 1/3 up top. It's got one more third, and then y squared over this. Well, we got to flip that up first. And so it's y squared times y to the 4/9. And so we're going to add those power. And that ends up being 2 plus 4/9 is 22/9. Because 2 is 18/9. 18/9 plus 4/9 is 22/9. Over here, we're going to add and subtract them. So it's very similar to number 6. Adding and subtracting, they got to be the same. So we're going to take this cube root of 81 and make it 27 times 3. Cube root of 27 is 3. So it's 3 cube roots of 3 plus 1 cube roots of 3, which is then 4 cube roots of 3. All right, now we got compositions. This is just g minus h, and we just add and subtract like terms. The domain still has to be that square root of x here still messes with the domain. We still can't plug in any negatives. Oh, this is the domain of 17. That's kind of tricky. So it's looking at the domain over here. Again, it's still going to be square roots, so we can't have any negatives. G times f of x, this is just foiling. F over g, well, just can't do anything but can't have 0 in the denominator. All of these domains end up being no negatives under square roots and no zeros in the denominator. All of these are just compositions. G of 2 is a number, and then that number goes into f. G of f of 2, figure out what f of 2 is, and then plug that number into g. And then these are just abstract ones. Again, the domain goes back to the original. So you can't look at this x minus 6 and look at the domain. You got to look at the domain of the actual composite functions. So we can't get the domain here. This is when this says domain of number 17, it doesn't mean that. It means domain of 12. This is the domain of 12. Down here, this is the domain of 17, and this is the domain of 18. So I guess that should really be a 2 there. Verifying these are inverses of each other, right? So this is doing f of g of x and making sure you get x, and then doing g of f of x. So take f of x and chuck it into g, and this take g and chuck it into f. So take this, right? Oh, the x plus 4 over 3, and then throw it into that input x. And then so instead of 3 times x, you get 3 times g of x minus 4. The 3's cancel, and then x plus 4 minus 4 is x. And you can see that work. Finding the inverse functions. Okay, see this is x to the 4th, so it's kind of like a smile. So we got to delete. In this case, we're taking x less than 0. So we're going to delete the right side, and we're going to switch the variables, x and y, and then we're going to solve for the new y, and we're going to get this guy. And then this will have an inverse because we've only defined the left side, so we only get the negative side of this. This is a cubic one, so we don't have to do anything. We just do the solve, and again, we're going to solve for the cube. We're going to end up getting a cube root. So no calculator, so this looks just like the cube root, except it's up 2 and it's a little steeper. This looks like a square root, but it's to the left 2 with this one. It's up 4. It's going to go down instead of up, and the slope's going to be a little less than what it normally is. Normally it goes up 1, over 1, over 4, up 1 type situation with square roots. Instead, it's going to be a little less. Right? So our parent function, which is kind of the normal one, is just our normal. So this is going to be left, up 4, and then it's going to go down a little slower than normal. And again, down because of the negative, slower because of the half, left 2 because of the plus 2, and then up 4 because of the plus 4. All those shifts. And again, here are the shifts here. No domain and range restrictions for cubics or cube roots. And then we cannot have this thing be negative, so we got to start at -2 or bigger, and then the range goes from 4 and it goes down. So when we write range, always go down to up. So we got to go negative infinity all the way up to 4. Okay? Solving equations, right? We're going to take this to the 5th power, both sides, and then solve. Here we're going to move the 3 and then square. Here we're going to multiply by 2 and then apply the 3/2 power. Why? Well, because it's the reciprocal. If we want to get rid of the 2/3 power, we have to use the 3/2 power. Over here, we're just going to square both sides. We are going to always have to check for extraneous solutions when we're squaring things. If the original thing had square roots like 27 and we square both sides, the quadratic might give us 2 answers, but one of them probably won't work. So check them both, and it looks like -6 is extraneous here. And on this one, it looks like we do get 2 solutions, but they both end up working. So just make sure we check our answers, especially when we have square roots or anything to the even root. You're going to have to check to make sure you didn't actually get a negative when you plugged in under there. But absolutely on the test, going to have to solve equations, checking extraneous solutions, just like the directions say, domain and range, graphing cubic, or cube root functions and square root functions with all the shifts and stretches and talking about the domain and range, inverses, finding inverses, verifying inverses, composite functions, and then all of these exponential type rules. But this is really similar to the test, so certainly you want to go over this review and make sure you understand all these principles.